Let me start over again. Volume of a cone would be 1/3 the volume of a cylinder with the same height, the same base area. Except, what is the base of a cone? What shape is it? It's a circle, right? So our capital B for the base area would just be what again? Pi r squared, just like with the cylinder, but it's 1/3 of the cylinder now, okay? So let's look at some examples. And they should look fairly close to what we did with pyramids, right? Except the pi r squared part. So here's one with a radius of 3, and the height, as usual, is measured perpendicularly to the base, right? Which also gives you what kind of triangle in there should you need it? A right triangle, Pythagorean theorem, special right triangles, and trig functions, and all that other stuff that you learned, right? So 1/3, here's our capital B, here's our H, okay? And most of the time we'll leave them in terms of pi, exact answers, okay? Over here, the only trick is we don't know the radius, but we can figure it out quickly. It is what? So pi times 6 squared times 4, 1/3 of that, and you get 48 pi cubic centimeters. Now over here, they give us, the 13 would be called what height? What height is that called? The slant height, right? Which doesn't help us directly, but it does indirectly. Because the radius here is 5, we have this right triangle, and hopefully you know what this triple is and you don't have to do this. It's a 5 what? It's a 5, 12, 13. That gives us our height. Okay? Plug it in. There's base, there's height. Okay? Simple enough. Any questions on that? Sounds a lot like yesterday, doesn't it? All right, let's go through some examples here. You're going to do these. All right, I'll give you a few minutes to work through those. So all you work like you know how to do. All right, and then we'll take a look at them. Get the first one yet? What do we get? 325 cubic centimeters. It's as simple as volume equals 1/3 pi, radius 8 squared, times 17. What do we say, 320? Cubic centimeters. Easy enough. Second one's a little bit trickier. What do you have to do in the second one? Yeah, big cone volume minus a small cone volume, right? Big cone minus small cone. We get this one yet? I'll give you a minute. How about now? He says 117 pi. Maybe we agree with it. Yeah, I agree. A couple of you? All right. Well, you need to get the radius of the big one up here, which is what? Oops. What's the radius of the large cone? 6 centimeters, right? So simple enough. Now we have enough to plug and chug, right? So the big cone would be 1/3 pi times 6 squared times its height, which is what, 16, minus a small cone, 1/3 pi, and its radius is 5, and its height is 9. All right, and you can plug all that in your calculator, you know, well, pi for now. 117 pi cubic centimeters. And we'll leave it exact right now because it's not really in context of anything. You understand that? Like, if you were an engineer, you would take this value, and you and your engineering team would decide how much precision do we need to build this thing or design this thing, right? Make it work well. And you might all agree you need 4 decimal point precision, and then you would, you know, do your approximation, whatever's practical. Okay? All right, and I'll give you a minute on the third one here. You might have to sketch in one little part there to kind of see what's going on, or to use something, a tool that you've learned before, so you can figure that out. What's not provided in this one? The height. So that might be the thing you want to sketch in. Okay, better take it away. we'll form some other figure in there that will be helpful to you. Now, hopefully you've figured out that this is the thing you need to sketch in here, right? And it does become a 30, 60, 90, doesn't it? This is our height. It's one side of that. So that's 60 degrees there. And this is 30 degrees up in here, right? So maybe if I identify it as a 30, 60, 90, but the way the picture is drawn, it's kind of tough to tell which one's the long leg and the short leg, because what do you need in a 30, 60, 90? You need the short leg. So how can we identify which goes to the short leg, guys?
The long leg's the opposite of
Well, the opposite hypotenuse is the right angle.
yeah.
It's opposite of the short of 30.
Yeah, you got a 30-degree and it's a 60, right? The short leg will be across from the 30, which is, hey, isn't that the height we need? Right? And that 3 centimeters is what? The long leg. So now you just have to remember how to go from the long leg to the short leg of a 30, 60, 90. How do you do that? Divide by the square root of 3, right? Yeah. And then you're going to want to do what? So 3 divided by it. Can't leave it like that, right? What are you going to want to do that? Yeah, rationalize it by multiplying it by 1. Now let's see who can finish this out. Go ahead, take a shot at it. Just shout it out.
3 squared root of 3.
Well, we're missing one thing.
Pi.
Pi. 3 pi square root of 3, yeah? No? Well, good look at it then. So now we have the height. We got the radius. That's all we need for volume, right? So volume. Am I recording? Yes, I am. Equals 1/3. What is it? Pi times what?
3 squared.
3 squared times what? Oh, wait, I didn't finish this out, by the way. So, let me do this. Get this in, right? Let me do this part first. So, what do we have here? 3 squared to 3 over what? Oh, no, just 3, right? Square root of 3 times the square root of 3 is 3, isn't it? Is it the square root of 9, which is 3? Or it's the square root of 3 squared. They don't do each other, right? And then, what now? Yep, so you just left with square root of 3. Right? Let's don't even get your calculator, right? What's 3 squared? 9. What's 1/3 of 9? So 3 pi square roots of 3 cubic centimeters. You good on that one? Okay. A little bit more, you had to pull in some tools we've learned, right? But I told you that's the case, okay? All right, so it's a lot like the pyramid thing, but let's go and look at some of these Regents questions then. Again, you might want to draw a sketch for certain things. Try this first one. You probably really don't need a sketch in the first one. So are we solving for the volume in this one, guys? What are we actually solving for? So we're going to have to use the volume formula, and everything will be in there except the H part, right? What is the radius? Yeah, okay, yep. Good, you're not making that mistake. No. Oh, yeah, we're solving for that. I was just looking to see where's the height in this thing. Yikes. So that's my setup. I like to have my variable on left. That's that's what I'm solving for, but that's, leave that up to you. As long as it's organized and presentable. And say the actual answer. 15, there we go. How many got 15? All right, good. So, first thing you can divide out, just write as what? The pies, right? And probably the best thing to do is just do 3.3 squared and then divide that by 3. What do you got there? Like 3.63? H. Simple enough. 3.63H is 54.45. And H is 15 centimeters. 23. Okay, moving on, number 2. Better shrink this down a bit. Is there a step we have to take here first before we jump into the volume formula? Huh? No. Yeah, it's not a triple, obviously, because there'll be whole numbers there, right? So if this is our height, all right, would it be h squared plus 2.5 squared equals 6.5 squared? The hypotenuse is always the one by itself in that Pythagorean theorem, right? So h squared 2.5 squared equals 6.5 squared. Let's see, h squared plus 2.5 squared would be 6.25. What's 6.5 squared? 0.25. Subtract 6. What you got? Oh, that comes out nice, doesn't it? So height equals 6. I'm surprised they didn't put that down there as a choice, right? All right. You know, get the height there. Now we just, again, just plug and chug. 1/3 pi 2.5 squared times 6. What do we get? Yeah, okay, so they left it exact, right, in terms of pi. So 12.5 pi. And that is, again, in cubic centimeters. All right, not too horrible. Well, I bet you guys wish you could take this test, huh? All right, maybe someday. You just sit in on one for fun. I'll be there. You know, for fun. This one's okay. So this is an interesting one. Definitely going to want to draw a sketch of it. I know I have to. And I will put it right in here. Whoops. Seems like a decent enough spot to put that. All right. What's the radius of this thing? 1.5, right?
Yep.
Okay. Let me ask you a question. Shouldn't we just find the volume of that cone and then take, and then wouldn't, if you fill it halfway, wouldn't that just be half the volume? Just intuitively, think of the shape. Okay. Well, let me get through this angle of it. Think of the shape of it. If I fill it halfway with water, will that water be half the volume of the whole cone? What? You think if it was a cylinder, you'd have something, right? You see what I mean? Because the dimensions of the cylinder don't change on the way down, but what? Yeah, right? So like the cross sections change as you go up, don't they? Get wider and wider. The radii change, right?
Is there cross section, like when you go this way, always in this direction?
If your cross section is parallel to the face, yes. Remember that we did conic sections, right? If you do it like at an angle, you get an ellipse, an oval, right? If you kind of get to one side and go through it, you get a parabola. You get two of them stacked up and you get a hyperbola, which you don't know what that is yet, but. Okay, so yeah, hopefully you just intuitively, you know, right now, you can't just find the volume of the cone and divide it by 2. It's volume of water. So probably, well, what do I say changed as you go up, fill the water up, farther and farther? What do they say changed? We're talking about the cross sections being different, and then what do they say changed as you went up with the water level? What measurement?
The height.
Okay, the height, that's true, I guess, yeah. But I was after another measurement that changes as well. As you go up, and it gets wider and wider, what's changing?
The diameter.
Yes, but the thing we use in the volume formula,
Radius.
right? Doesn't the radius change as you go up? Right, so the height is originally what, 4 inches here?
Yeah.
4. Okay. And how far? So what's the height of the water then? If we're only filling it halfway.
2.
So that would be like about here, right? So that would be a new radius here, wouldn't it? And that height is 2. Okay. Let's go back and think about what we learned. You see a couple of triangles there? What can you tell me about those 2 triangles that might be helpful? Because this is one, maybe you're looking at it from a different angle, and that's fine, but remember, you know, even if you are, you might be correct in how you're looking at it, but we like to look at it from various different angles and reconcile them all. What can you tell me about these 2 triangles here? There's this little one and the big one. They both have a right angle, and they both share an angle down here. So what are they?
Similar.
They're similar. And what do you know about similar triangles? Diagonals? You know, it wasn't that long ago.
Both sides are in proportion.
Okay, they're proportional corresponding sides. In other words, they have a scale factor, don't they, a K? Right? If we thought of this as a dilation, what does our K equal, our scale factor?
2
1/2,
or 1.
so right? Big and small. Want to be a half? Okay. So that means all the corresponding sides are in a 1-to-2 ratio. Right? So how do I find this R?
You divide with like 5 by 2.
Yeah, well, the way I wrote it here, we multiply it by half, wouldn't we? K times the 1.5, and what do you get?
3.
So you get? About you half times that. You doubled it.
0.75.
Right? You guys see how we got that new radius? Did anybody come up with the 0.75 thinking of it differently? Sure you, come on. I mean, I approach it with similar triangles, or actually dilation, right, the scale factor. Maybe you set up a proportion. Or maybe you just thought 1/2 felt right. I don't know, either way. All right, you got enough information now to get the volume of the water? Good. Oh, good talk, guys. Is this what you like, it's like an interrogation, you're not talking? Do you have enough information now to get the volume of the water? Well, let's think about the formula for volume. Volume equals 1/3 pi r squared h. Do we have an r? Yeah. Do we have an h? Okay. So To answer my question, I guess yes. And it looks like pi will go in your calculator. How do you know that? Yeah, you know, look at your answers too, right? Everybody get it? What'd you get?
4.7.
4.7 he got. What do you guys think? Tyler, you don't think so? What do you get?
I got one.
Yeah, I got one.
Yeah, I got 1.18, which, you know, 1.2 is what around through the choices, right? So let's take a look at that. So volume equals 1/3. Did you forget the 1/3 thing?
I did 1/6 of the total. Because it's half.
Okay, explain that then. I'm not sure. 1/6 of the total volume of the cone?
So what I did was I did 1/6 pi 1.5 squared multiplied by 4. And I got 169 pi, and I got 1.5 pi. Then I multiplied and I got 4.7.
So you're thinking that the volume should be 1/6 the size?
1/3 times 1/2. 1/6.
Oh, okay. There it is. So you're thinking you got half a cone worth of water then. So what you did mathematically was what we kind of eliminated when we were talking earlier, right? You took the volume of the entire cone and just divided it by 2. Right? Which doesn't work because it's not a cylinder, right? The dimensions change as you fill the water up. So it's not like it's not what we call a linear change. Does that make sense? Okay? Yeah, you did exactly right. It's not, so you're kind of treating it like a half a cylinder or something like that, right? You put a half in the formula. It's not quite because we cut it this way. You know, maybe if we cut it that way, somehow the water stayed in, you'd have something, right? Okay. So anyway, it comes out to 1.18. What is it? Cubic inches, which corresponds to 1.2. All right, let's hit this last one here. There's a measurement they don't give you, but they give you enough information to find it, and it's something we've done a couple of times before. Okay? Circles, and I think another time with a cylinder. So what's missing from the problem? What measurement is missing that we need to find here for volume? Radius. Do we remember how we go about finding the radius given what they gave us? Why? What is it? Okay, yeah. Well, careful. Okay. Well, hope for a full sentence there, right? You said some things that, if it was in a full sentence, would be correct, I think, right? Economic communication. They gave us the circumference of it, right? But the formula for circumference has what in it that we need? The R, if we use it right, you know, not the pi d one, but the 2 pi r one. So C equals 2 pi r, always, right? And in this case, specifically, what does C equal? All right, so if I want to find the radius, what should I do with these two things? If both of those things equal C, then what can you tell me about both of those things? So 2 pi r equals C, and yeah, if they both equal C, then they're equal to each other, aren't they? Yeah. So 2 pi r must equal. And what do we do to both sides? And here's why I need you to be careful. Right. Right, so that goes away, right? What do we get for the radius? Do we get something different? 49.35 for the radius. And you're not the only one in the history of this course to get that, and I will tell you exactly why. Think for a second. Just not quite. Think for a minute. Would the radius be 49? Would I get 40? I mean, be like this, wouldn't it? Right? And the diameter would be twice that, right? You're up about 100, was it inches, centimeters in diameter? What mistake did you make when you put that in your calculator? Yeah, right? So what you did, and it's a real common mistake, remember, the horizontal fraction bar, guys, is also a grouping symbol, isn't it? We divide by the whole thing, but your calculators don't do that algebraic look like that, right? So you have to do the 31.416 divided by parentheses 2 times pi, close parentheses, right? You get pi? 5, right? You guys get that distinction, right? Try not to make that mistake as you go forward in life anymore, okay? So you got a radius of 5. So now we can go through the file we need to find, right? Oh, what was the height? 13, thank you. So what's our volume? To the nearest cubic centimeter.
340.
Yeah, point nothing, right? No decimals, okay? Because that's what they said. So volume equals 340 cubic centimeters. All right, everybody okay with that? What was the last one? Yeah, okay. It's not a whole lot different, but they did put a couple of different twists in there, right? We've seen the one where if you need the radius and they give you the circumference, you all get it now. It's pretty easy to do, right? You just set their circumference equal to circumference formula and get what you need, okay? All right, well, your problem set then will be all problems. There's not many of them. Okay?